Well. Welcome back to the Module 5 of the Foundations for Machine Learning. Uh, this is pretty much a lot of difference between machine learning and the data analysis we did earlier on. Um, so I encourage us to be very attentive. It's going to be very simple. We're going to take it easy, and we will not really dive deep into the coding from scratch in this course, but I want to introduce to all of us the foundations of machine learning to the point at which whenever we talk about it or someone's talking about it out there, you can contribute immensely. Uh, you are going to move from zero to a mid table in this course. I'm not promising you're going to be an expert yet because it takes a lot of time. Myself, I'm not an expert. I'm still learning. But once more, I encourage you to take this very serious. It will be very useful in the future. At least you will understand what machine learning is. It's a buzzword out there. Yeah, everybody talks about it. But not everybody that understands what they are talking about. So, but now for you taking this course, at the end of this course, you should be able to understand um, what machine learning is. Um, you should be able to differentiate between supervised and unsupervised machine learning. You should be able to talk about train test split. You should be able to uh, um, contribute to the conversation concerning or around linear regression, logistic regression, and classification metrics. We'll also talk about supervised learning. I will focus on K-means clustering. I know this sounds like jargon right now, but at the end of this course, you should be able to understand this and to be able to talk about it whenever you are out there. Then there's a model evaluation and model best practices, machine learning best practices. This is also very important because a lot of people stop at understanding what is supervised and unsupervised learning, but model evaluation is as good as the model itself uh, because it helps us to understand or to evaluate which model is best to be used for a particular problem. So this is going to be a fun to be in. It's not going to be very hectic like the previous course we did because that was very hands-on. We did a lot of coding there. But this time I understand we are all beginner and I'm taking a very beginner approach for this course. So what is machine learning? Machine learning is not magic. It's as simple as pattern recognition. But this type of pattern recognition is at scale. Think about it. Think of the skill set of 1,000 minds joined together on a single machine. Yourself, you were able to do a lot of things because you recognize a pattern. Not everything you see clearly, but everything you just thought about it. This is a pattern and this is how we're supposed to go. So think about it. Let's put yourself 1,000 persons or 1,000 individuals as yourself together to think about something and to be able to bring out a decision in a split second. So it's just a very high, powerful pattern recognition system um, at a very high scale. So we'll talk more about pattern recognition and but in the previous modules, as I said earlier on, you learned about cleaning data, exploring and describing data. We also learned about how to visualize it. Now we have a new question. Can we really teach a computer to make predictions or to find patterns automatically? So this is the core question now. Can we teach computer to learn some major step that we have been taking every day to learn from our data point and to be able to predict what we're going to do based on the data point that we have given to it? So this is what exactly uh, what machine learning does. So the focus, like I said, is on understanding what each algorithm does, why it does it, and based on your experience or your understanding of the previous codes that we've written, you will see a lot of similar syntax here as well, but we are not here to code a lot. But the real machine learning in the future, if you want to advance, then you can put more effort into the coding aspect. So how to use this notebook? I encourage you to read every markdown cell carefully. There will be an existing code in the code cells. Um, I'm not expecting you to write it from scratch. It will be given to you, but I want you to read it. It's well detailed. There are a lot of comments on the codes, which will tell you what each lines of codes are doing. So code cells are short. We made sure it's short, so you run them and focus on reading the output. We have some reflection questions, which I will encourage you to pause for a moment and think about it before moving on. Our practice challenges will be gentle this time as compared to the previous ones. I could ask you to change one or two things, but I will not ask you to write this complete code from scratch because I cannot do it myself right now. Yeah, I copied most of the codes here, so don't think I did it from scratch. Um, so setup. In the previous lessons, we established our modules, how we called upon different modules to do some work under the hood for us. So we'll do the same thing here. We run the cell below, this cell below, just once, so that we can load the libraries that we're going to use. And we also need to load the market sales data set from module 2. So the market sales data set we're going to use here is the clean version. I don't remember if it's in module 2 or not, but if you remember, we have a particular version that we output. I think it's from module 2, which we call market sales clean.csv. So this is what we're going to use. So I'm expecting you, before you do this course, you should have completed module 2. If you have not, then I'll encourage you to go complete your module 2 course, then come back here so that we can write together. So you may wonder why we have a lot of what we call sklearn modules. Oh yes, welcome to machine learning course, because sklearn modules are responsible for the high computation that we do or that the machine does under the hood for us. That makes it to be able to recognize a particular pattern in our data set, and as a result also uses that as a prediction. So sklearn is a shortened form of SciPy toolkit-learn, which is a scientific computation in Python, SciPy. So sklearn is a very important module which you will get to see a lot. As you see here, we have a lot of sklearn here, and as you see, the first one is sklearn.model selection. This is the one that we're going to use to split our data. We'll talk more about that. And sklearn.linear model is the one that we're going to use to call the regression models that we're going to use. There are two main models, which is logistic and linear. We also have a sklearn.cluster. This is going to be used for unsupervised learning. And we have sklearn.preprocessing. This is going to be used to preprocess our data, such as scaling down high values or encoding our category value into to make it numeric, easier for the computer to understand or to do mathematical operation. So the last one is sklearn.metrics. This is going to be used to check how well our model is performing. That's where we're going to use it for evaluation, which I already established earlier on. So without further ado, let's just go right straight in. The first one, as our habit is to load our data into what we call a variable data here, right? Data. So how do we do that? I said earlier on that we have an output called a market sales clean.csv, which is a product of our clean version of market sales tutorial, right? So we go to the folder icon, go to upload, then you should have go to wherever you save your output, but make sure it is market sales clean version. Load it in. As you can see, I already have my song somewhere in my folder, and I've put it in here. So now I should be able to run it. But before you run it, make sure you run the models first. The modules first. As soon as you get the module first, then run the um market says clean CSV file. Make sure you have this output that shows like it's ready. Then from there we can continue. What is machine learning? So let me give you a simple analogy. My dad used to be a cocoa farmer. When I was growing up, I noticed like there are some period that they keep the farmers, the cocoa farmers, they kind of keep their cocoa up to that period. They wait to that period before they push it out to the market because they believe, based on historical knowledge or historical experience, that at this particular period, cocoa price goes up. And to make sure to have the highest profits, you need to push out your product at the right period. So this is just using his 10 years or 20 or 30 years of experience as a cocoa farmer to understand what is the best time for him to push out his cocoa for sale. So that is just a very low level explanation. Now put that on a very high scale it up. That is what your machine learning does. Another analogy here that we use is imagine you are a market trader who has been selling rice for 10 years. Over time, you notice when the harvest is good, price drop. When it rains heavily, fewer buyers come. So, and you also notice like prices are always higher in December. So this unconsciously, it's a pattern that you have recognized unconsciously, and it is just from experience. So, but that experience now is a data point. It's a lot of data point that you have gathered unconsciously. Now you use that to make prediction that during December, definitely you're going to have a very high amount of sales. Uh, it is December and harvest was poor, so I expect high prices. So as soon as the harvest is poor, so prices will definitely go up. So machine learning does exactly the same, but with a computer and thousands of data points instead of one person and 10 years. So let's compare traditional programming versus machine learning. In traditional programming, I know some of us here are programmers. If we are not, then we should have like an introductory level course in programming. We understand that programming is a lot of rules, logics, and we use the data on that logic to bring answers. So, but in machine learning, it's otherwise. Machine learning, you already have the answers based on some data points. Now you want to have a model. A model it's what an algorithm has identified in the data set and has saved as a standard of operation or standard of prediction. So that's what we call a model. So we can call it rules as well. So in traditional programming, you write every rule by hand. But in machine learning, you show the computer many examples and it figures out the rule itself. Isn't that that's cool, man? So example, instead of writing if price is greater than 300 and quantity is less than 50, then high value is true. Instead of doing that, you should just show the computer 10,000 past data points or transactions that you have labeled high or low value. And it could learn that on its own. So anytime you put any price that is greater than 300 and the quantity is less than 50, then it has a very high probability of saying or predicting it to be a high value. So that is the basics of machine learning. As I have said earlier on, it's working mostly on your historical data point and using that to generate a rule, which we call model, in order to use it for prediction for the future. So we have three types of machine learning. We have the supervised learning, we have the unsupervised learning, we have the reinforcement learning. The supervised learning typically works with a labeled examples. We call a labeled example as, take for example, you sell ice cream and you have an amount of money you make every day on ice cream. So the amount of money is the label based on the day or the transactions of the day or the particular period. So we also call it target. It's our target because the result is the money that we made from the transaction that was made all throughout the day or within a period of time of the day. Another thing is, take for example, you do not want to say the specific amount of money, but you want to say if you have a high sale or low sale. And you say based on your transactions, the ice cream you sold for a particular day, if you made more than $50 in a day, you want to call it a high sale. And if I made less than $50, I want to call it a low sale. So that's that kind of example or that kind of problem definition is called a classification problem. When you categorize your target, your label to be to be in a category rather, when you make your label or your target value, your target variable to be a category, then we call it a classification problem. But if you make it a number, it is a regression problem. So a regression predict a number, e.g., what will total sales be next month? While a classification predict a category, e.g., example, what will be our sale? Will it be high or will it be low? So that is classification. Unsupervised learning. Unsupervised learning, as against the supervised learning, does not have any label. You put in your data, the transactions you made, like the sales you made, for your ice cream, you put in the variables or the features. The features is going to be the date or the time the transaction was made, uh, the temperature of the moment the transaction was made, um, the location where the transaction was made, and the value or the outcome or the sales amount of the transaction. So all of this data, all of this variable in this data point, you place it, you push it into a machine learning model, and you say you want to group it into similar items. So at this time, we do not really have a target variable. We just want a grouping. We want to see which or what transactions look similar, or what sort of or what type of transaction, how many transactions can you group together and say these are transactions that look similar. It could group them based on the temperature. Maybe the transactions were made, so there are some specific transactions that were made based on the temperature. Maybe it was less than 50 degrees that day. So a lot of people bought ice cream between the hours of uh, uh, maybe 2 p.m. to 5 p.m. when it was a little bit hot. But when the temperature dropped around maybe in the evening, people stopped buying ice cream, something like that. So that is just to categorize transactions or whatsoever your data set is into different category and bring them together. Like these are very similar transactions, and you can just sort it into different categories. So in this place, we don't deal with label. We just push our data into the model, and it gives us the similarities in transactions and put them into different buckets. So think of it like sorting a pile of mixed fruit into groups by color and size. If you have maybe a box of apple, sometimes apple could be of different colors. Sometimes a light green, sometimes deep green, sometimes you have like a wine colored apple. So if you are given that kind of box and you are told to separate them into different buckets or clusters, let's start using cluster now. We call that kind of category clusters. So you are told to put them into different clusters. So one thing you can do is like you can put different apples in um you can put some apples in the same box based on their sizes, right? If you see like this apples are big in they are big, you can put them in a particular box. And you can also put some apples based on their color. Based on their color, you can cluster this apple and put them based on their color. So that is just mainly what clustering or unsupervised learning is all about. So nobody needs to tell you the groups. You found them by yourself. So a machine learning model also does that easily. Reinforcement learning, we are not going to talk much about this, but we need to have an idea of what reinforcement learning is. So take, for example, pretty much reinforcement learning is, call it trial and error. When a computer learns by trial and error, even a young baby, a chap, most of the time we learn by trial and error, right? Maybe one day you've been told not to touch iron that you used to press your clothes. But because you have never experienced it, you touched it and it burnt you. So the next time nobody will tell you not to touch it because you know the result. So reinforcement learning operate based on the principle of penalty and reward. So if a if a model that you are training does something right, you reward it. If it does something wrong, you penalize it, such that next time at that scenario, that data point, when the model is about to make a decision, it's going to remember the last time I did this, I was penalized. So rather than doing the decision I made that got me into a problem, I would try another decision. So by the time it does another decision, if it gets it right, you reward it, then it moves to the next step of learning. So gradually over time, it understands all possible patterns, all possible movement to make in order not to get penalized. So this reinforcement learning, if you have heard about this artificial intelligence model that does play chess, yeah, it does. It uses reinforcement learning because over time it has learned what are the moves it's going to make that's going to gain reward based on the opponent movement. So that is pretty much about reinforcement learning. So the computer learns by trial and error, receive reward for good action and penalties for bad ones. It's typically used in a game, AI, and robotics. Like I said earlier on, I don't think we should dive deep into this, but I want you to just understand this as part of the type of uh, machine learning that we have. So, what are the ML workflow that we have? Like we defined during our time with data analytics course, we defined the problem, right? It's pretty much this almost the same thing, but just some nuances added to this. So the first thing is to define your problem before you approach any machine learning question or solution rather. You want to define the problem clearly. From there, you will know what to predict. From there, you will know if it's if it's a reinforcement learning you're gonna use, or if it's an unsupervised learning approach that will be used, or a supervised learning. So the next one is gather your data, prepare your data, clean, encode, and select the features to be used for prediction. As you heard from our previous guest speaker, who said 80% of the time we spend using preparing the data in a real life scenario. So, and if you could remember clearly what we did in data analytics courses, we had a lot of data preparation, code that we wrote there. We took time in doing cleaning and coding. Sorry, we never encoded, but we cleaned and I think we categorized. We took some time there. And we also selected features by choosing some particular columns that we want to use in a particular operation. So when you have that ready, when you have prepared your data, the next one is to split the data. So splitting the data into training set and test set. We will talk more about this, why we need to split the data. And then the next one is we have to train the model. Uh, so training the model is more of a let the algorithm learn from the data that we have. So you train the data on the training data or training set. This is where the algorithm sees pattern in our data set. This is where the algorithm sees that cocoa farmers have a better tendency of high profit if it sells its cocoa product around December every year based on previous scenarios. Uh, this is where the algorithm will detect. It will learn from the data that and says ice cream sales usually comes good during the summer. Why? Because most of the time between this period of the year, we have high sales generally, typically. Um, so this is what we call a model. Model is a result of an algorithm that has learned the data and has saved it as a standard of operation or prediction. Um, so the next one is evaluate your machine learning model. Evaluate what you have. How well does it perform on the test data? So after you've trained on the training set, you evaluate on the test data. we're going to talk more on that later. So evaluation is just checking how well it does perform, because we don't want to just train a model one time thing and you feel it's good enough to go ahead for production. No, model training is an iterative process. You need to do it multiple times and get and use the one that gives you the best result for that specific data that you're training. And the last one is interpret and improve. As we said earlier on during our course, data analytics course, we emphasize on communication, communicating our insights, interpreting what we have gotten into top level, C-level executives to understand and to break it down from the mathematical jargon that we have or from a lot of data that we are crunching, just to isolate them from looking into the more complex part. So interpretation and improve. Interpretation is just explain what your model is trying to tell uh to tell you based on your data, and improve on it based on what you have. You can improve on your model by adding more data in the future, or fine-tuning it in a way that it will improve your results. Um, Before we go further, I need us to understand some key for vocabulary that we're going to be talking about. We're going to talk more about this vocabulary, so we need to be familiar with them. The first one is a feature. You probably have heard me talk about feature. Feature is an input column used to make a prediction. Sometimes I call it variables. Sometimes I might call it columns, but the standard name for the standard term is feature. So feature from our market sales data set, we have maybe a lot of features, maybe 5 or 6 or 7, I can't remember. 1, 2, 3, 4, 5, 6, 6. We have 6 features. So features are the columns that you have on your data set. Minus the target. So the target is the one that we are that is of interest to us, is the one that we are very interested in. So the target is the column that we want to predict. Sometimes we call it label, or most time we call it target. Now, features, from part of the features, one of it will be the target, and that is specific for regression problem, right? For a supervised regression problem. Yeah. Okay, it could be also a classification problem, but just for supervised problem generally. So a target will be one of your feature on your data set. Just remember that. So a model is a set of rules the algorithm learned from. The algorithm learned from the data and use it as a standard. So I already established that. So what do we call training? The process of algorithm learning from data, that's training. Then prediction is the model's output for a new unseen data point. Then we're going to hear about a lot about accuracy. That's how often the model's predictions are correct. Uh, we're told to look at the market sales data, the one that we have, to look at the columns. And which column do you think will be features? And which columns do you think could be a target? I have a code here that you can run that will give you this output. If you run it, it's supposed to get something like this. Do not mind this. This is just a format. So you can just put column here, suppose. Yeah, but it will not format it pretty good. So we wanted to have more space. That's we have expand this space room to give it more clarity. Well, I believe that we are familiar with all other codes here for column in data.columns. We did that already. We printed in F string the column and the data type. So this is how we got the data type. We just use the data and the column. These are the columns. The column date, products, quantity, price. We are just iterating through the data.columns. You remember we did that earlier on. So for every columns, we want to check the .d type for every column. So this is how we got this. So this is just showing the printing a string out. So you don't, I believe you understand all these codes. So now features, which columns would you say will be the features and which columns will be the targets? Please take some moments and think about it. Come back and answer. Yeah, welcome back. I believe you taking some time to look at it. For me, looking at this, we say total sales will be something I'm very interested to predict in the future. And as a result, I call that my target variable. And the orders will be my features. Some may say price per kg, but for me, I mean, this is very subjective. For my preference, I would prefer to predict sales based on other features that I have here. So notice that the same column can be a feature in one problem and a target in another. It depends on the question you are asking. So if the person that gave you the problem says they want to understand what would be their possible or estimated sales come next month. So definitely you have to use total sales based on the previous uh, data points that we have for the different products. We use total sales as a target variable. But what if they want to predict the price per kg based on the total sales? Then you have to use price per kg. That's why understanding the problem is very important before you dive deep into the solution. So these are the examples of how to know which approach to use for a specific problem. So given the product, city, and quantity, predict the total sales. Total sales is a numerical value. And when you have numerical values at the target or the label, definitely, typically, that is a regression a regression problem. The next one is given the product and city, predict whether sales will be high or low. Anytime you have a category as the output, like high, low, 1, 0, yes, no, anything regarding similar to that, it's a classification problem. It is also under both of these, regression and classification, they are all under supervised learning. Remember that, do not mix them up. The last one is when you want to group all transactions into different segments, that is clustering. Since we don't care about a label or a target at this point, we just want to group them into similar transactions into different segments or buckets. Then we'll be talking about clustering. And remember, this is an unsupervised learning because we don't care about the label output. So practice challenge, go through this and let me know from whatsoever you get your output. Let me know if you have any challenge on the WhatsApp group. But run this code and write your answer in the cell below. No coding rather, just write your answer. Or you can put it in a new markdown cell. So Thank you so much for listening, very attentively rather. Sorry, I'm not the first English speaker. I'm just trying my best. Um, then from here, we can move to the next one, uh, on the next course next time. So see you next time, but until then, keep coding. Thank you and have a good time.